So far we have discussed the motion of objects that can be treated like a point, and we looked at their path that looked like parabolic in shape, like what we see here with the black curve. Now, in real life, as you have observed, when you toss an object, it might have a more intricate pattern of motion. There are things, for example, that affect the motion of an object as we toss it. A resistance that we've been ignoring so far, and that we are going to continue to ignore in this lesson, plays a big role in the motion of objects. That gives the spin, for example, to tennis balls or baseballs or soccer balls or footballs. And actually, in the design of those balls, they purposely trying to take advantage of air resistance. That's why, for example, the tennis ball is not a smooth ball. Those whiskers in the ball, they were designed purposely to take advantage of air resistance. The dimples in a golf ball were designed purposely to take advantage of air resistance as well. That applies to the shape of a football, all of the above. Air resistance plays a role, and an important role. However, we are not discussing this here. What I would like to discuss a little bit, the size of the object. Objects usually do not have all the mass concentrated in one point. And for example, like represented by this object, I have two masses separated by a certain distance, like a dumbbell. If you toss it, it's not going to look, its motion is not going to be as easily visualized as the motion of a parabola. However, the important thing is, what about its center of mass? And we'll talk about the center of mass later on. The average position of its mass. The average position of its mass is going to still follow a parabolic path. Okay, let's go to the simulation. This is my simulation. This is my dumbbell. So I play it, and you see what happens. The center follows a parabolic path, and here we are showing the motion of the red mass, the path of the red mass, and that's more intricate. Okay, now to just make sure that we know what I'm talking about, what we are talking about, I'm going to increase the mass of the blue ball drastically and see what will happen. Now, the blue ball is going to look like it is following the parabolic path, because the center of mass is essentially at the position close to the center of the blue ball. Let's reverse it. Let's make the red ball much bigger. And you notice there, the path of the red ball is almost the same as the path of the center of mass. I'll make it even larger. I need to first reset it before I do that. And we don't see the deviation anymore right now.